Look at networking services and technology. Google provides an array of services which help you with your network requirements. It provides you connect capability in terms of how do you connect to Google Cloud Platform from on-premises, other cloud platforms, or even from SaaS applications. How do you scale your network? How do you make it secure? And what are the different options to optimize your network? When it comes to connect, these are the options. Let's look at hybrid connectivity, and we will be looking at some of these services in much more detail. Hybrid connectivity provides you high performance options such as dedicated interconnect and partner interconnect to flexible low cost cloud VPN solutions, and also it provides you peering solutions to access Google APIs. Then there is Network Connectivity Center. This product is in preview right now, but when it becomes GA, this will be one of the most important product in the Connect category. Network Connectivity Center, it provides a single place to manage global connectivity. Virtual private cloud, which is the virtualized topology of a network, and we have looked at it. Cloud DNS, it's a scalable and reliable DNS service which is running on the same infrastructure as Google. Service directory, it's a single place to publish, discover, and connect all application services. When it comes to scale, there is cloud load balancing, which we have discussed before. It basically puts all of your resources behind one single anycast IP. You have external load balancers and internal load balancers, and it connects with integrates with Cloud CDN. Then you have Cloud CDN, which is the content delivery network. It's basically leverages Google's own globally distributed edge caches, and this is very important to have your data available around the globe, and also to a lot of those places where there is no native connectivity. Then when it comes to secure, Cloud Armor, it works with an HTTPS load balancer to provide built-in defense against infrastructure DDoS attacks. Then you have CloudNet. It's a Google Cloud's managed network address translation service, which enables you to provision application instances without public IP addresses to access internet. Then you have network telemetry. It keeps your services secure with in-depth network telemetry. It can identify traffic and access pattern that may impose security or operational risks to your organization. Then you have VPC Service Control, which allows users to define a security parameter for API-based services. So a lot of time we use VPC where we create all our instances, but then these services also need to access Google Cloud storage as well as the API-based services like BigQuery and Cloud Bigtable. So it helps you create a security parameter for those services. Then when it comes to optimize, you have Network Intelligence Center, which provides comprehensive network monitoring of your network with proactive network verifications. Then you have network services tier. Network services tier, there's primarily two. Premium tier and the standard tier, which is basically how fast your connection is. So let's look at hybrid networking. Network connectivity is Google suite of products that provides enterprise connectivity from on-premises network or from any other cloud provider to the VPC networks. Now, when it comes to connectivity, what are the different ways where you want to connect to from your enterprise? You want to be able to connect to Google Cloud. Then you want to be able to connect to Google Workspace or Google APIs. By Google Workspace is if you're using Gmail suite of products. Google APIs, it could be YouTube, Maps, or any of the Google products where you access it using their APIs. And you should be able to connect to the CDN providers, which is the delivery network. When it comes to connecting to Google Cloud, you have an option of Cloud Interconnect, which provides low latency and highly available connection to Google Cloud. So you can access Google Cloud VPC networks and the instances internal IP addresses directly from your network without using any NAT device or a VPN tunnel. Now, when it comes to the interconnect, which is literally just the direct connect to Google Cloud, there are two options: dedicated interconnect or partner interconnect. Now, dedicated interconnect works if your enterprise resides in a co-location facility close to Google. Then you can use dedicated interconnect. But if your enterprise is in a far away or remote areas where Google doesn't have a data center or it's not available, you can use the partner interconnect, where basically the partners create that co-location facility with you, and then they map it to the Google's network. So you have these two options depending upon where your enterprise is located. If you are located in the same place, dedicated interconnect, it basically gives you a 10 gigabytes per second or 100 gigabytes per second pipe to connect to Google Cloud. When I say pipe, so you can choose up to 8 10 gigabytes per second pipes. So that means total 80 gigabytes per second. Or if you are using 100 gigabytes per second pipe, you can go up to 2 of them. So that takes it to 200 gigabytes per second. So in a sense, from 10 gigabytes per second all the way to 200 gigabytes per second kind of connectivity you can get using dedicated interconnect. But if it is partner interconnect, you can use from 50 megabytes per second to 50 gigabytes per second connectivity. Now, with that, let's look at what if I am not looking to utilize interconnect, because of course it's a dedicated and direct connection to Google. It is a bit expensive, and my requirement is not that much. So then the option is Cloud VPN. Cloud VPN securely connects on-prem and cloud VPC network to the Google VPC network through an IPsec VPN connection. IPsec VPN connections have been in the industry for quite a while, and the traffic that travels between these two networks is encrypted by one VPN gateway and then decrypted by the other VPN gateway. So Google Cloud offers two types of cloud VPN gateways: high availability VPN, which has a very high SLA, then a classic VPN. Now, where you should use high availability VPN versus classic VPN is high VPN only supports dynamic routing, but classic VPN supports static routing, which is policy based, route based, and as well as dynamic routing using BGP, which is the border gateway protocol. Now, when you should go for an cloud VPN connection is that each of these VPN tunnels can support up to 3 gigabytes per second total for ingress and egress. So what that means is, if 3 gigabytes per second connectivity is good enough for you, cloud VPN is much more affordable and secure and a good secure solution. Now, next one is cloud router. So cloud router, it's a fully distributed and managed Google Cloud service that uses the BGP protocol to advertise IP address ranges. It programs the dynamic routes based on BGP advertisements. So if you don't understand BGP, it's fine. BGP is more about, it's a kind of a broadcasting service for different networks, and there's a broadcaster, and then there is a receiver. So, and each cloud router is implemented by software tasks that basically act as BGP speakers and responders. Now, keep in mind that cloud router is not a connectivity option, but it works with Cloud Interconnect and Cloud VPN. So, for example, if you use a Cloud VPN tunnel to connect your networks, you can use Cloud Router to establish a BGP session with your on-premise router over your Cloud VPN tunnel. So Cloud Router automatically learns new subnets in your VPC network and announces them to your on-premises network. Next, if you want to connect to just the Google Workspace and Google APIs, the option is Cloud Peering. Cloud peering is purely just to access Google Cloud features over the internet. So any of the Google sites, any of the Google services. Now with peering, there are again two options: is the direct peering and the partner peering. Direct peering basically gives you direct connections to Google. Partner peering is through a partner. Then there is Cdn Interconnect to connect to CDN providers. Cdn Interconnect enables selected third-party CDN providers to establish direct link with Google's Edge network at various locations, which basically enables you to direct your traffic from your VPC networks to a provider's network. So, and a typical use case for CDN Interconnect is high volume egress traffic and also the frequent content update. Now let's look at Cloud Interconnect. Cloud Interconnect, which provides a low latency, high available connections that enables you to reliably transfer data between your on-premises and Google Cloud virtual private cloud networks. So as we discussed in terms of dedicated interconnect, it all depends on the co-location facility. If it is closer to Google's network, you can use dedicated interconnect, which is again, you have a cloud router on the Google side, and then you have an on-premises router, and they work through BGP sessions. Then you have partner interconnect. Now partner interconnect you will use if you are not close to Google's location or Google's facility. In that case, you will be using a service provider who will peer with you, and the service provider will peer with Google's network. Again, in this case also, you have on-premises router, and then you have the Google cloud router. So they do they use BGP to do the broadcasting of the services. This way it can recognize the IP addresses. Next, another thing to remember, VPC network's internal IP addresses are directly accessible from on-premises network. So if you spin up a machine here, then whatever the IP, the internal IP, this from the on-premises network, they can directly access that internal IP without going through a cloud NAT or any kind of other VPN requirements. As we mentioned, co-location facility, dedicated interconnect, you get 10 gigabytes per second pipe. You can get up to 8, which is total of 80 gigabytes per second. With 100 gigabytes per second pipe, you can get 2 of those. Partner interconnect, 50 Mbps to 50 Gbps. Next, let's look at Cloud VPN. Cloud VPN securely connects your on-prem and cloud VPC network to Google VPC network through an IPsec VPN connection. So in this case, this is the on-premise network, Google Cloud network. It basically connects these two networks through an IPsec VPN tunnel. So on the on-prem side, you have the on-prem VPN gateway. On the cloud side, you have the cloud VPN gateway. So on the one side, this encrypts, this one decrypts the data. Traffic between the two networks is, as I said, encrypted by one VPN gateway and then decrypted at the other VPN gateway. Cloud VPN gateways, there are two options. High availability VPN, which has a higher SLA, and then you have classic VPN. High availability VPN only supports dynamic routing using BGP, but the classic VPN supports static routing and dynamic routing. And then each cloud VPN tunnel can support up to 3 gigabytes per second, and this is what is important, is that if your requirement is only up to 3 gigabytes per second, then it's a very low cost and a good option. And then also Cloud VPN uses a maximum transmission unit of 1460 bytes, and it supports IKEv1 and IKEv2 using a shared secret. With that, let's move on to Cloud NAT. So Cloud NAT, it's a network address translation, which lets VMs instances without any external IP address and private Google Kubernetes Engine clusters send outbound packets to the internet and receive any corresponding established inbound response packets. So the instances within Google Cloud Platform, they can access internet without having an external IP address. So with your internal IP address, you would be able to access internet. It's a distributed software-defined managed services, which means that it is not based on a proxy VM or appliances. So when you are connecting to internet from your internal IP addresses, there is no machine here which it goes through. It's a software defined managed services, which helps with the scaling part of it. So if we look at this, each VM is programmed by GCP to NAT using assigned ports. So this particular one, NAT IP this, and it has a defined port of 300 to 363. When you come here, it is 32000 to 32063. So each one of the machines have a defined assigned port which he uses through NAT to connect to internet. Security, which is subject to egress firewall rules. VMs without external IP addresses can access destination on the internet. Availability, because it doesn't depend on any VM, you get a very good availability, and also it's scalable. So as and when you keep adding more and more machines, it will become more and more scalable because it doesn't depend on any virtual machine to route the request. And performance, because it does not depend on a VM, it does not reduce the network bandwidth per VM. It's software managed service, so it just scales on demand. With that, now let's look at VPC Service Control. So VPC Service Control defines security policies that prevent access to Google managed services outside of a trusted perimeter. It blocks access to data from untrusted location and mitigates data exfiltration risks. So if we take an example of a typical scenario using Google Cloud Platform, you have an on-premise which is connected through Cloud Router. Cloud Router is basically routing the requests to Google's cloud projects, which is, you have any authorized VPC network project which is connected to on-premises. Then this particular project also needs to access its data, which could be hosted on cloud storage or BigQuery, which are API based system. So you have authorized VPC network, and then you have data residing on API based services on GCP. Now, what you do basically is that you create a service perimeter around it. Now, with this service perimeter, the unauthorized clients can't access your authorized VPC network, even if they might have a stolen credentials. Same goes for internet. They can't access from the internet even to your API based services where your data sits. And also the unauthorized projects within GCP, they might be connected to on-premises as well, to the same on-premises, but they are not authorized to view the specific data, or they are not authorized to use these machines. So even they won't be able to access it. You can use VPC Service Control for use cases like isolating Google Cloud resources and VPC network. So in a company, you can have multiple VPC network, multiple VPC projects, but maybe it's because of customer data or some compliance requirements. You can isolate one particular, like few cloud resources and some VPC networks into a service perimeter. You can extend perimeter to on-premises network. And also you can control access to the Google Cloud resources. So Google Cloud resources, maybe you might have a requirement that some project should be able to access data, some project shouldn't be. So you can monitor those. Then you can also context-aware access to resource. So it's based on client attributes by using ingress rules. With this, now let's look at network service tier. So network service tier lets optimize connectivity between systems on the internet and Google Cloud instances. Premium tier delivers traffic on Google's premium backbone, while standard tier uses regular ISP networks. So premium network, basically you have Google Cloud platform region. Then it goes through, all the traffic goes through the Google network. Traffic only exits at the Google network near destination. So end user, ISP provider, the traffic terminates at the point of presence, where basically Google interacts with the ISP network. So for the most part of it, traffic stays within Google's own network. This is called cold potato rating. So egress traffic is sent through Google's network backbone, leaving at a global edge point of presence, very close to the user. On the other hand, standard tier, you have the Google Cloud provider here, platform, and the traffic straight away gets into ISP's network through point of presence, which traverses through internet, and then it again offloads at the service provider's location. This kind of routing is called hot potato routing. So egress traffic is sent to the internet through a peering or transit network local to the Google Cloud region from which it has originated. By default, premium tier is enabled unless you go and enable a standard tier. Network Connectivity Center, which I talked about, it's in a preview mode right now, but when it becomes GA, it will be really important because it provides a single management experience to easily create, connect, and manage heterogeneous on-prem and cloud networks. And with a lot of investment going on into multi-cloud networks, this will become really handy. So Network Connectivity Center will give you a single pane of glass to connect to different on-premises sites as well as other cloud providers. So using the same management interface, you can use interconnects to connect to on-premises network. At the same time, some of the sites you can connect through VPN, SD-WAN, and then even to the interconnect partner. Now, what it gives you is single connectivity model. So it provides the unique ability to easily connect and manage VPNs, interconnects, SD-WANs, all of the connectivity options we looked at. Then it gives you a flexible cloud connectivity because it will give you a unified connectivity experience by connecting to Google's cloud infrastructure, leveraging new or existing partners, dedicated interconnects, cloud VPN connections, and a third-party router or SD-WAN. Then it will give you a VPN-based multi-cloud connectivity because a lot of enterprises are on AWS, GCP, and Azure. So this will give you one unified place to connect to other cloud providers as well. Then the SD-WAN integration and the third-party router is very important because it can be used as the default landing point when you are integrating with SD-WAN or other routing solutions. And then the real-time visibility for the global network, because it will provide you a single pane of glass for connecting to, again, VPNs, partner, dedicated interconnects, and on-prem network. It also pairs seamlessly with Network Intelligence Center for end-to-end visibility. So I hope this was useful. Thank you.